So the first question, if the transmission values for radiochromic film exposed to 0 and 275 centigrade or 5500 respectively, what is the net optical density corresponding to 275 centigrade? So as we know, the optical density formula is log I naught by IT for log 10 equals, so as we know the values, I naught is 5000 by 500, 5 ones are 5 tens are, so it gives us log 10 to 10, which is 1. The answer is B. Now second question, if 6 MV beam is calibrated as 1 centigrade equals 1 mu for a depth of 1.5 centimeters, 100 centimeter SAD technique, but the beam data tables are accidentally labeled as 1 centigrade equals 1 mu for a depth of 1.5 centimeters, 100 centimeter SSD. So this is the accident. So as the result of this accident, what is the delivered dose? The delivered dose will be systematically dashed than expected. So first let us see if it will be more or it is less, then we will try to rule out what is it. Okay, so in SAD technique, if this is the source, this will be your 100 centimeters, this will be your surface, this is the depth 1.5 centimeters that they have prescribed, so the total distance will be 100 centimeters from here to here. This is SAD technique. Okay, now if this has wrongly calibrated as SSD technique, so this will be 100 and this will be 1.5 centimeters. This is the SSD technique at the depth of 1.5 centimeters. So the total distance over here is 100 plus 1.5, that will be 101.5 centimeters distance. So since the machine is delivering at 100 centimeters 1 mu, what will be the dose at 1.5 centimeters, 101.5 centimeters? So that will obviously be lesser. So now as we know, we have ruled out more, it won't be more, it will be lesser. Now it will be 1.5 lesser or 3% lesser. So now let's put the inverse square law, or 1 by r2 whole square. So d2 is what we have to calculate, d1 and r1 by r2 whole square. So d1 we know it's 1 mu, at r1 is 100 centimeter, r2 is 101.5 whole square. Now we are calculating 100 into 100 divided by 101.5 divided by 101.5 gives us 0.95 d2. So that is telling us it is 97% of the d1. Okay, so if it's 97% of the d1, it is obviously 3% lesser. It is obviously 3% lesser. So the answer over here is D, 3% lesser. Now 39th question is, which detector is more accurate for dosimetric measurements of small, that is 1 into 1 and 3 into 3 photon fields? So as you know, parallel plate, this is asking for photon, parallel plate is for electrons, and well chamber is for radioactive sources. So these two are ruled out, and farmer's chamber is for photons, but it is for larger fields. The chamber itself is very big, so it cannot measure for 1 into 1 for 3 into 3. A free air ionization chamber is for measurement of exposure in the air, so that is also ruled out. So the answer is silicon diode over here.